Welcome to our notes on operations on matrices. Students will be able to perform operations on matrices such as addition, subtraction, scalar multiplication, and multiplication. So what is a matrix? A matrix is an array of numbers. These numbers are called elements of the matrix. So in order to talk about a matrix size or dimension of the matrix, we have to understand the concept of rows, columns, and how we name the element based on the row and column. So a row is horizontal, while a column is vertical. So let's come to matrix A, where I have all of these elements in the array. Little a sub 1, 1, or little a sub 2, 1, or little a sub 3, 4. We have to understand what that means. So if I am in row 1, then the very first number in my subscript is going to have a 1 there. Okay, if I was in row 2, I would have 2's being the first number of my subscript. So I'll just write that here. So this is row 1, and this is row 2. And I can have the ith row, m row, however many rows there are for this matrix. This matrix could be super large. So now let's talk about the columns. So column 1 is going to have the second number in the subscript be all 1's. Column 2, similarly, I'm going to have 2's as the second number of my subscript. So in this matrix, I have a total of m rows and I have a total of n columns. The size of the matrix is going to be the number of rows by the number of columns I have. And I usually write that like right around here for the matrix whenever I'm looking at the dimensions or trying to find the size of the matrix. Example 1. Let matrix A be defined as the following. By the way, this notation right here is useful because when I handwrite, I would use a square brackets in order to handwrite and to let me know or let you know that I'm talking about a matrix. So just like vectors can be bold or you could draw the half arrow on top, a matrix, it should be bold as well, or you can do square brackets around it. Part A says, what are the dimensions of matrix A? So in order to find the dimensions, I need to know how many rows and how many columns I have. So I'm going to count. I have 1, 2, 3, 4 rows, and I have 1, 2, 3 columns. So this is a 4 by 3 matrix. Part B says, what is the element A sub 3 2? So this 3 means I'm in the third row, and that 2 means I'm in the second column. So here is the third row, and here's the second column. That intersection is the element A sub 3 2. Why don't you try example 2 next? In order to add and subtract matrices, both matrices must be the same size. So to add or subtract is pretty straightforward. If I highlight these things here, notice how A sub 1, 1 and B sub 1, 1 are in the same positions of their respective matrices. When I add the two matrices, I just add those together. So here, I'll pick another one. I would add these two together because they're in the same position. So I just take whatever elements are there and I add them or subtract them. They work the same. And that's it. Example 3, perform the operation below. Here we have subtraction. The first thing I want to do is I want to make sure that both of these matrices have the exact same size. I can see from inspection that they do, but just for good measure, let's figure out the dimensions of both matrices. So I have 2 rows and 3 columns, and here I have 2 rows and 3 columns. So they are the same size, so I can actually subtract. I'm going to show you all the work as to where I get everything from, but feel free to skip this step if you understand where it comes from. So I'm going to have a 2 by 3 matrix in the end. So the first element in the first row in the first column is going to be -5 minus 6. First row, second column, 2 minus -5, -2 minus -6, 4 minus 1, -2 minus 3, and 0 minus -3. So now I'm just going to actually perform those. -5 minus 6 is -11. 2 minus -5 is 7. -2 minus -6, that is a +4. 4 minus 1 is 3. -2 minus 3 is -5. And 0 minus -3 is a +3. So there I have my 2 by 3 matrix, and I'm done. Why don't you try example 4? Scalar multiplication of matrices is quite simple. If you let C be a scalar, you just multiply C by every element in the matrix and you're all set. Example 5, perform the operation below. I know that this is scalar multiplication because the number on the outside of my matrix is a number, a scalar, or a constant, however you want to think about it. I'm going to multiply that constant, which is 4, with everything, every element of my matrix. So again, I'm going to show my work, but feel free to skip this step if this is a step you understand whenever you show your work. You just need to make sure you do everything correctly. So then you can go right to this step if you understand it. But just to show you where everything comes from, there we are. This is a 3 by 1 matrix. It should be the same as the matrix you're multiplying the scalar by. So why don't you try example 6? Okay. Matrix multiplication is a little bit different than scalar multiplication. In fact, it's a lot different. So suppose you have matrix A and matrix B. If matrix A has the dimensions m by n, remember m is the number of rows and n is the number of columns, then matrix B must have dimensions n by p in order to multiply matrix A and matrix B. The resulting matrix C will have dimensions m by p. The very important piece of information is that if you're doing matrix A times matrix B, remember m by n, n by p, these numbers have to be the same in order for you to multiply. And then the matrix C, as we said above, is going to have matrix m by p. So if I use a different highlighter here, so m by p, that's what's going to happen. So that's a colorful way of remembering. These have to be the same. What I'm going to do is I'm going to color code right now all of the subscripts for matrix A, B, and C. And I want you to either use the same colors or identify your own colors. That's fine. Just make sure you stay consistent. Whatever I colored pink, you need to color whatever color you chose, etc. Be right back. Alright, so now everything is color coded. I want you to pause the video and highlight your subscripts accordingly. Be very careful. Make sure you pay attention whether or not I highlighted the row or the column part of the subscript and in what color. Now, typically before you try to multiply, just make sure you can multiply. Here I have a 3 by 2 matrix, and matrix B is a 2 by 3. Well, because the number of columns in my first matrix equals the number of rows in my second matrix, I can actually multiply them, and I will get the resulting 3 by 3 matrix that I see here. So here's a warning. I'm going to mark up these matrices just to show you what I'm doing, since I can't like hover over with the cursor or something to show you where I'm at or what I'm looking at. But I will be deleting them or moving them around, so just be aware of that. So when you multiply matrices, you multiply the row of the first matrix times the column of the second matrix. And it's actually a linear combination of these things. So let me show you where that goes. It's going to go here in the first row, first column of your resulting matrix. So notice in matrix A, I highlighted the row green, row 1 is green, and column 1 in my matrix B is pink. And so that is where I'm going to be in my matrix C. The calculation we have here is A11 times B11 plus A12 times B21, and that will end up in our C11 spot. Suppose I wanted to know what was going to be in the first row, second column of matrix C. Well, in order to get that, I need to multiply the first row of matrix A with the second column of matrix B. So I'll actually do that right now. It will be A11 times B12 plus A12 times B22. All right, so let's pick another one, and then I'll fill in the rest. Suppose I wanted to know what would go here. So in order to do that, I need to be the second row of the first matrix, and I need the third column of the second matrix. So in order to get that, I do A21 times B13 plus A22 times B23. And I'll actually finish the rest of this, so I'll be right back. All right, here's the rest of it. Go ahead and pause the video and record it on your paper. So here's example 7. We have two 2 by 2 matrices, so we can clearly multiply them. So we have a 2 by 2 and another 2 by 2. So we will in fact end up with the 2 by 2. So what I'm going to do is I'm going to show all my work, and I highly recommend that you do every time you multiply matrices as well. I'm going to color code everything, make it look nice, so I'm going to pause the video and I'll be right back. Okay, example 7 is now complete. I did some further color coding just to say which row, which column I was focusing on when. So hopefully that helps. Go ahead and try example 8.